Bitwise operators in Python. Today we'll talk about bitwise operators. We'll discuss the various bitwise operators of Python. These are bitwise AND, bitwise OR, bitwise XOR, bitwise ones complement, bitwise left shift, and bitwise right shift. Consider two numbers 5 and 7. The binary for these are 101 and 111 respectively. The 0b is to denote it is in binary. Now 5 and 7 gives us 7, but 5 bitwise and 7 gives us 5. So we see and bitwise and are not the same thing. Let's look at what's happening. 5 and 7 is equivalent to true and 7. True and anything returns the second value, so this returns 7. Now for the bitwise AND, 5 and 7 is the same as 0b101 and 0b111. This gives us 0b101. Let's see how. 1 and 1 is 1, 0 and 1 is 0, and again 1 and 1 is 1. This is the binary for 5. So we see bitwise operators can work on 1 or 2 operands, and they operate bit by bit. We have 6 types of bitwise operators in Python. These are AND, OR, XOR, ones complement, left shift, and right shift. Let's see how the first 3 operate. AND, OR, and XOR are binary operators. They work on 2 operands at a time. The AND logic says 0 and 0 is 0. 0 and 1 is 0. 1 and 0 is 0, but 1 and 1 is 1. So by this logic, the AND operator gives us a 1 only if the bit is 1 for both the operands. The OR logic gives us 0 only if the bit is 0 for both the operands. For the rest of them, it gives us 1. XOR stands for exclusive OR. It gives us 1 if the bit is 0 for one of the operands and 1 for the other. For 2 zeros and 2 ones, it gives us a 0. In Python, 1 symbolizes the Boolean value of true, and 0 symbolizes that of false. Let's see the AND operator in action. 4 and 8. The binary for these are 0, 1, 0, 0 and 1, 0, 0, 0. Now by the logic we just discussed, 0 and 1 is 0, 1 and 0 is 0, and 0 and 0 is 0. This gives us 4 zeros. This is the binary for 0. To summarize, the AND operator performs the ANDing of corresponding bits in the 2 operands. Let's take some more examples. You cannot AND 2 strings. That results in a type error for the operator. 0 and true gives us 0, the binary for which is 0b0. You cannot AND 2 floats. You can AND binary values. This one gives us 0b0100, which is binary for 4. If that was easy for you, you'll have no problem with the bitwise OR operator. 6 or 1. The binary for these are 110 and 001. Now 1 or 0 is 1 and 0 or 1 is 1. 111 is the binary for 7. The bitwise OR operator performs the ORing of corresponding bits in the operands. Now let's talk about the bitwise XOR operator. 6 XOR 3. The binary for these are 110 and 011. 1 XOR 0 is 1, 1 XOR 1 is 0, and 0 XOR 1 is 1. This is binary for 5. So we see The bitwise XOR operator performs XORing of the corresponding bits in the two operands. Time to talk about the unary operators. 1's complement of 2. The binary for this is 1, 0. We begin with the rightmost digit. 0 becomes 1. And now since we've reached a 0 by now, everything else follows as it is. This gives us minus 0B11. Pay attention to the minus. This is the binary for minus 3. Summing up, the bitwise 1's complement returns the 1's complement of a number's binary. Let's take one more example. 1's complement of 45. The binary for this is 101101. We start from the extreme right. 1 becomes 0, 0 becomes 1, and everything else follows as it is. Now this is the binary for minus 46. So we conclude this operator inverts bits until it reaches the first 0 from the right. Also, 1's complement of x is equivalent to minus x minus 1. 1's complement of 45 gives us minus 46, and that of 2 gives us minus 3. Now let's talk about the left shift and right shift operators. 3 left shift 2. The binary for 3 is 1, 1. When we shift it to the left by 2 places, it gives us 1, 1, 0, 0, which is binary for 12. So you see, the left shift operator shifts the number of bits by the given number of places to the left. What happens to the newly generated places is that it fills them in with zeros. Let's take another example. True left shift 2. As said earlier, the binary for true is 1. The left shift operator shifts this to the left by 2 places and gives us 1, 0, 0, which is binary for 4. Finally, the bitwise right shift operator. The binary for 3 is 1, 1. If we shift it 1 place to the right, we are left with 1, which is binary for 1. The right shift operator shifts the bits by the given number of places to the right. It drops the bits in the places it loses. Let's take one more example. The binary for 31 is 5 ones. If we shift this 3 places to the right, we are left with 1, 1, which is the binary for 3. Interesting? Keep learning and don't forget to try it out yourself.